Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day I bid to Dr. Azrina and my fellow friends. My name is Muhammad Haziq bin Rozaimi. In this video, I'm going to talk about one of the most basic yet important aspect in highway and traffic engineering study, which is noise. When we talk about noise, how can we describe it? Is every sound that we hear in our surrounding, in our everyday life, is considered noise? Or is there any specific criteria that we can think of when we talk about noise? To put it simply, noise is every unwanted sound that is disturbing and irritating to anyone who hear it. It is in fact a type of pollution that can affect one's health physically and mentally. In environmental points of view, noise pollution mostly comes from the traffic noise. Traffic noise is generated from our transportation system, which consists of our vehicles and the transportation media, such as roads, railways, airports, and many more. The traffic noise produced is come from our vehicular engine noise, as well as from the friction of the vehicular tire with the roadways. The sound waves produced can be described by two basic parameters, which is frequency and amplitude. As we all know, frequency is the number of waves produced over a period of time. It can be measured in the units of cycles per second. Amplitude is the measure of loudness of the sound wave, which can be described in the units decibels. Traffic noise can vary considerably over a short period of time. Therefore, traffic noise is denoted by L10. L10 is the noise level that exceeds 10% of the specified time. The measuring unit for the traffic noise is usually in dBA. In engineering practices, the noise level study is usually conducted to assess the noise level at the specified location. The noise level reading will be recorded for every specified time span over a specified time duration. Later, the data will be analyzed by plotting the S-curve and the frequency trend graph to obtain the value of L10, which L10 is the noise level that exceeds 10% of the specified time. To conduct this experiment, the apparatus needed is very minimal, which we will only use a noise level meter and a stopwatch. The noise level meter will be used to determine the noise level reading, while the stopwatch will be used to monitor the time span for every noise level data recording. This is the digital sound meter, or also known as noise level meter. Let's take a look at the function of the meter. Press the red power button to turn the meter on. The display shows the current sound level. The meter's default sound level unit is decibels. To switch to zone, press the dB zone button and the meter will display the current sound level. To return to decibels, press the dB zone button again. Across the upper part of the display is a bar graph showing the current sound level within the current selected range. Notice the two numbers located on either side of the bar graph indicating the minimum and maximum values of the current range. If the sound level picked up by the meter is below or above the selected range, the words over or under will appear under the maximum or minimum range values. To change the sound level range, press the up and down arrow located at the bottom of the meter to switch to the appropriate range. In the upper left corner of the display, the meter shows the sampling speed. The meter's default speed is fast, which represents the instantaneous sound level. To switch to slow, press the fast slow button and the meter will now display the average sound level. To go back, press the fast slow button again. To keep the current reading on the display, press the hold button and the current reading will stay on the screen until the hold button is pressed again. If you want to see the maximum level recorded by the meter, press the max button and the display will hold the maximum value measured by the meter since the max button was pushed. To return to normal, press the max button again. The meter measures sound level or sound pressure using two different weighting modes. The A weighting mode, which simulates the hearing characteristics of the human ear and more closely represents the sound level a person would hear. To switch to C weighting mode and measure the actual sound level pressure, press the AC button and the meter will switch to C weighting mode. To return back to A weighting mode, press the AC button again. After this, I'm going to conduct the traffic noise study in my housing area in Seremban 2, Negeri Sembilan. My housing area is located near the main road, thus there is noise-related issue faced by the local residents. However, due to some limitations, there will be some modifications on the apparatus used during the study. Now, I'm at the main road in S2 Heights. This road connects all the 10 housing areas in S2 Heights. Therefore, this road is usually busy with vehicles, especially of the local residents of S2 Heights itself. I'm going to conduct the traffic noise study in this road. I'm going to collect the traffic noise level data for every 30 seconds in 30 minutes period. These data are important, especially to determine the L10 value. So, without further ado, let's get started. For safety purposes, it is advisable for us to wear light colored clothes, even during daytime, to avoid any unwanted accidents from happening during the study. To conduct the study, I'll be using the traffic noise level meter mobile application as a replacement of the laboratory traffic noise level meter apparatus. This mobile application will enable us to detect the average noise level data at a certain time. Besides that, there is also a timer installed inside the mobile application. Therefore, I will not have to use any stopwatch to monitor my timing. So, to collect the noise level data, all we have to do is very simple, which is firstly, just point the noise level meter towards the source of noise. Then, after that, make sure to record all the noise level reading on a piece of paper. I am now recording the noise level reading for every 30 seconds. The reading shown on the noise level meter mobile application will be jotted down on a piece of paper. For a proper data presentation, this is how we tabulate our collected data from the study. We have to construct a 4-column table. The first column will be the range of noise. The second will be the frequency. The third will be the percentage of frequency. And the last column will be the cumulative percentage of frequency. After filling all that, we can calculate the L10 value from the displayed formula. Next, we have to plot the S-curve graph of noise versus the cumulative percentage frequency of noise. From there, we can get the L10 value. Lastly, we have to plot the frequency trend graph of noise versus time. From there, we will also be able to get the L10 value. In conclusion, noise can be very irritating if it is not managed properly. Mitigation measures should be taken to reduce the noise level produced. One of the ways is by reducing the speed limit of the road. By doing so, the friction between the vehicular tires and the roadways can be decreased. Thus, reducing the noise produced. I think that's all from me for this video. Thank you.